The inspector may consider this to be bundling under the National Electrical Code section 300.3c, which states that conductors entering or leaving an equipment enclosure shall not be bundled. It might be argued that the conductors are not bundled but simply routed together to achieve a more efficient and organized installation. The conductors are not strapped together or contained within a common sheath, which is typically considered bundling. To determine the correct interpretation, consider the following aspects. Firstly, the intent of the code. The NEC aims to prevent issues such as overheating, damage to insulation, and potential arcing hazards that can occur when conductors are bundled. Secondly, the specific situation. In this case, the conductors are routed individually through framing members, which provides some separation and reduces the risk of the issues mentioned above. Thirdly, local jurisdictional rules. Some local jurisdictions may have specific interpretations of the NEC regarding what constitutes bundling. Here is a recommended course of action. Discuss the situation with the inspector and explain your reasoning. Provide evidence of the separation between the conductors. If the inspector is not convinced, consider making adjustments to the installation, such as spacing the conductors further apart or using a wire tray or conduit to route them separately. If necessary, consult with another qualified electrician or electrical engineer for an additional opinion. The inspector's concern about bundling is valid. The specific situation in the installation may not meet the strict definition of bundling according to the NEC. By providing evidence of separation and understanding the intent of the code, it is possible to work with the inspector to resolve the issue and ensure a safe and compliant electrical installation. When dealing with electrical installations and inspections, understanding the nuances of the National Electrical Code, or NEC, is crucial. One area that often leads to differing interpretations is the concept of bundling conductors. This involves how closely multiple wires are grouped together and the potential impact on their performance and safety. Let's delve deeper into this topic to provide a comprehensive understanding. Firstly, it's essential to define what electrical bundling means. Bundling, in the context of electrical wiring, refers to the practice of grouping multiple conductors closely together for a certain length. This can occur when wires are physically tied together with cable ties enclosed in a common sleeve or conduit, or simply run parallel to each other with minimal spacing. The primary concern with bundling is heat dissipation. When electrical current flows through a conductor, it generates heat due to the resistance of the wire. This heat needs to dissipate into the surrounding environment to prevent the conductor from overheating, which can damage the insulation and potentially lead to electrical failures or fire hazards. When conductors are bundled, the heat generated by each wire can become trapped, increasing the overall temperature of the bundle. This is where the NEC comes into play, setting guidelines to ensure safe and compliant electrical installations. Section 310.15b3 of the NEC addresses adjustment factors for ambient temperature. The ampacity of conductors, which is the maximum current a conductor can carry safely, is affected by the ambient temperature in which the conductor is installed. If the ambient temperature is higher than the temperature rating of the conductor, the ampacity must be derated to prevent overheating. Similarly, Section 310.15b3 of the NEC provides adjustment factors for the number of current-carrying conductors in a raceway or cable. When multiple current-carrying conductors are bundled together, the heat generated by each conductor can raise the overall temperature of the bundle, reducing the ability of each conductor to dissipate heat effectively. As a result, the NEC requires that the ampacity of each conductor be derated according to the number of conductors in the bundle. This derating ensures that the conductors do not exceed their temperature rating, preventing insulation damage and potential fire hazards. The specific derating factors are outlined in NEC Table 310.15b3. For example, if there are 4 to 6 current-carrying conductors bundled together, the ampacity of each conductor must be derated to 80% of its original value. For 7 to 9 conductors, the ampacity is derated to 70%, and so on. It's important to note that these derating factors apply only to current-carrying conductors. Grounding conductors and neutral conductors that only carry the unbalanced current from a three-phase system are not typically counted as current-carrying conductors for the purpose of ampacity derating. However, if a neutral conductor carries a significant amount of harmonic current, it may need to be counted as a current-carrying conductor. In addition to ampacity derating, the NEC also addresses the physical installation of bundled conductors. Section 300.3c states that conductors entering or leaving an equipment enclosure shall not be bundled. This is to prevent excessive heat buildup inside the enclosure, which can damage sensitive equipment. Section 310.15a3 allows for the use of engineered solutions to address the heating effects of bundled conductors. This involves using specialized software or calculations to determine the appropriate ampacity derating factors for a specific installation. These engineered solutions must be approved by the local electrical inspector. It's also important to consider the type of insulation used on the conductors. Some types of insulation are more resistant to heat than others. For example, conductors with a high temperature rating, such as those with THHN or XHHW insulation, can withstand higher temperatures than conductors with a low temperature rating, such as those with TW insulation. When bundling conductors, it's generally recommended to use conductors with a higher temperature rating to minimize the risk of overheating. Now, let's consider some specific scenarios where bundling might be a concern. In a multi-family dwelling, such as a row of townhomes, it's common to have multiple circuits running from a central panel to various locations throughout the building. If these circuits are bundled together for a significant length, it can create a situation where ampacity derating is required. In a commercial building, such as an office building or retail store, there may be numerous branch circuits running throughout the building. If these circuits are bundled together in cable trays or conduits, it can also lead to ampacity derating requirements. In industrial settings, where heavy machinery and equipment are used, there may be large conductors carrying high currents. If these conductors are bundled together, it's crucial to carefully calculate the ampacity derating factors to ensure that the conductors can safely carry the load. To avoid the need for ampacity derating, there are several strategies that can be employed. Firstly, conductors can be spaced apart from each other to allow for better heat dissipation. This can be achieved by using cable trays with adequate spacing between the conductors, or by using individual conduits for each circuit. Secondly, conductors can be run in free air, which allows for maximum heat dissipation. This is often the case for service entrance conductors, which are typically run on the outside of a building. Thirdly, conductors can be sized larger than necessary to compensate for the ampacity derating. This is a common practice in situations where bundling is unavoidable. Finally, heat sinks or other cooling devices can be used to dissipate heat from bundled conductors. This is often used in industrial applications where large conductors are carrying high currents. Now, let's address the specific situation described, where a row of modular townhomes is being hooked up. The circuits drop out of the floor to the basement in a bundle, then must go about 30 feet to get to the panel. The zip ties were cut off and the conductors were pulled through a couple of framing members to get there. The inspector believes this is bundling, while the electrician does not. In this case, the key question is whether the conductors are sufficiently separated to allow for adequate heat dissipation. If the conductors are simply routed through framing members without any physical separation, the inspector may be justified in considering this to be bundling. However, if the framing members provide some degree of separation and the conductors are not tightly packed together, the electrician may have a valid argument that ampacity derating is not required. To resolve this issue, the electrician should first discuss the situation with the inspector and explain their reasoning. They should provide evidence of the separation between the conductors, such as photographs or measurements. They can also point out that the conductors are not strapped together or contained within a common sheath. If the inspector is not convinced, the electrician may consider making adjustments to the installation. They could space the conductors further apart by using additional framing members, or they could install a wire tray or conduit to route the conductors separately. Alternatively, they could upsize the conductors to compensate for any potential ampacity derating. Ultimately, the goal is to reach an agreement with the inspector that ensures a safe and compliant electrical installation. If necessary, the electrician can consult with another qualified electrician or electrical engineer for an additional opinion. It's important to remember that the NEC is a set of guidelines, and the interpretation of these guidelines can vary depending on the specific situation and the local jurisdiction. Therefore, it's always best to work closely with the electrical inspector to ensure that the installation meets all applicable requirements. In addition to the NEC, there may be local codes or regulations that also apply to electrical installations. These local codes may be more stringent than the NEC in some areas. Therefore, it's important to be familiar with all applicable codes and regulations before starting an electrical installation. When in doubt, it's always best to err on the side of caution and follow the most conservative interpretation of the code. This will help to ensure a safe and compliant electrical installation. In conclusion, understanding the concept of electrical bundling and the relevant NEC requirements is crucial for ensuring safe and compliant electrical installations. By carefully considering the factors discussed above, it is possible to minimize the risk of overheating and prevent potential electrical failures or fire hazards. Remember to always consult with a qualified electrician or electrical engineer if you have any questions or concerns about electrical installations. Their expertise can help ensure that your installation meets all applicable codes and regulations and is safe for use. In addition to the technical aspects of electrical bundling, it's also important to consider the ethical implications. As electricians and electrical engineers, it is our responsibility to ensure the safety of the public. This means that we must always follow the NEC and other applicable codes and regulations, even if it means going above and beyond what is strictly required. We must also be willing to speak up if we see something that is unsafe, even if it means disagreeing with our colleagues or client. Our primary responsibility is to protect the public from electrical hazards. By adhering to the highest ethical standards, we can help to ensure that electrical installations are safe and reliable for everyone. Finally, it's important to stay up to date with the latest changes to the NEC and other applicable codes and regulations. The electrical industry is constantly evolving, and new technologies and materials are being developed all the time. It's important to stay informed about these changes so that we can continue to provide safe and compliant electrical installations. There are many resources available to help electricians and electrical engineers stay up to date, including industry publications, training courses, and online forums. By taking advantage of these resources, we can ensure that we are always providing the best possible service to our clients and the public. Let's discuss some common misconceptions about electrical bundling. Firstly, some people believe that bundling is only a concern for high current circuits. While it's true that high current circuits generate more heat, bundling can also be a concern for low current circuits, especially if there are a large number of circuits bundled together. Secondly, some people believe that bundling is only a concern for enclosed spaces, such as conduits or cable trays. While it's true that bundling is more of a concern in enclosed spaces, it can also be a concern for open wiring, especially if the conductors are tightly packed together. Thirdly, some people believe that ampacity derriting is only required if the conductors are bundled for a long distance. While it's true that the length of the bundled section is a factor, ampacity derriting may be required even for short bundled sections, especially if the conductors are carrying high currents. Fourthly, some people believe that it's okay to bundle conductors if they are only carrying intermittent loads. While it's true that intermittent loads generate less heat than continuous loads, bundling can still be a concern, especially if the intermittent loads are frequent or of long duration. Fifthly, some people believe that it's okay to bundle conductors if they are using energy-efficient equipment. While it's true that energy-efficient equipment consumes less power, bundling can still be a concern, especially if there are a large number of energy-efficient circuits bundled together. To further clarify the NEC requirements for electrical bundling, let's examine some specific examples. Firstly, consider a scenario where 6 current-carrying conductors are bundled together in a conduit. According to NEC Table 310.15b3, the ampacity of each conductor must be derated to 80% of its original value. Therefore, if each conductor has an original ampacity of 20 amps, the derated ampacity would be 16 amps. Secondly, consider a scenario where 10 current-carrying conductors are bundled together in a cable tray. According to NEC Table 310.15b3, the ampacity of each conductor must be derated to 50% of its original value. Therefore, if each conductor has an original ampacity of 20 amps, the derated ampacity would be 10 amps. Thirdly, consider a scenario where 3 current-carrying conductors are bundled together in free air. In this case, ampacity derating is not required, as long as the conductors are spaced apart from each other and there is adequate ventilation. Fourthly, consider a scenario where 4 current-carrying conductors are bundled together in a cable with an overall jacket. In this case, the ampacity of each conductor must be derated to 80% of its original value, according to NEC Table 310.15b3. Fifthly, consider a scenario where 6 current-carrying conductors are bundled together in a wireway. In this case, the ampacity of each conductor must be derated to 80% of its original value, according to NEC Table 310.15b3. These examples illustrate the importance of understanding the NEC requirements for electrical bundling and applying the appropriate ampacity derating factors. By following these requirements, we can ensure that electrical installations are safe and compliant. It's also important to consider the impact of bundling on voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. When conductors are bundled, the increased temperature can increase the resistance of the conductors, leading to increased voltage drop. Therefore, it's important to consider voltage drop when designing electrical installations, especially when bundling conductors. To minimize voltage drop, conductors can be sized larger than necessary, or the length of the circuit can be reduced. In addition to the technical considerations, it's also important to consider the aesthetic aspects of electrical installations. Bundling conductors can create a more organized and professional-looking installation. However, it's important to balance the aesthetic benefits with the safety considerations. Bundling conductors too tightly can restrict airflow and increase the risk of overheating. Therefore, it's important to use appropriate bundling techniques and to leave adequate space between conductors to allow for ventilation. In some cases, it may be necessary to use cable ties or other fasteners to secure bundled conductors. However, it's important to use fasteners that are approved for electrical use and that will not damage the insulation of the conductors. It's also important to avoid over-tightening the fasteners, as this can restrict airflow and increase the risk of overheating. When working with electrical conductors, it's important to always follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and using insulated tools. It's also important to energize the circuit before working on it, and to verify that the circuit is de-energized using a voltage tester. Electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself from electrical shock. In addition to following safe work practices, it's also important to be aware of the potential hazards associated with electrical work. These hazards include electrical shock, arc flash, and arc blast. The electrical shock can occur when a person comes into contact with an energized conductor. Arc flash is a sudden release of electrical energy that can cause severe burns. Arc blast is a pressure wave that can cause injuries such as hearing loss and lung damage. To protect yourself from these hazards, it's important to follow all safety procedures and to use appropriate personal protective equipment. It's also important to be aware of the warning signs of an impending electrical hazard, such as the smell of ozone or the sound of arcing. If you suspect that there is an electrical hazard, it's important to immediately evacuate the area and notify a qualified electrician.